Okay, we're going to shift gears a little bit today and switch from talking predominantly about the client side to be talking about the server side. This is the other place where scripting can occur. And it's important right off the bat to recognize the difference in the purposes of client and server side scripting. And we reviewed this at the beginning, but I think it is worth it to go over this again. So let me bring up Paint so I can draw. We have, this is our general model. We have the client, which is typically someone using a computer or a mobile device that is connected to the internet and is making requests. We have a server at the other end of that request that responds to the requests. So these are key words in the client-server interaction: request and response. The client makes a request. The server gives a response. So the client makes a request by doing one of a few different things. Number one, you might type in a URL in your address bar. So if I open up my browser and I type in www.google.com, I am making a request of Google's web server. That request gets routed through the internet and ends up at Google's server, and Google sends a response. In this case, the Google homepage. So that is a request and a response. So that's one way that you can request a web page, or you can request something from the server, is by typing in a URL. Second way you can do it is same idea, but instead of typing in a URL, if you click a link. All right. You click a link, your request is sent to the appropriate web server. The web server responds with the proper page that has been requested. The third way is that the client has already requested a page and it's gotten back a form. And the user fills in that form and clicks like a submit button. That makes a request to the web server and it sends the data included in the form. In other words, great example of that would be if you go to Google. So I go to Google. That was a request for Google's homepage. They provide me this page. I type in something and hit enter or whatever. Did I just Google Google? I meant to Google PHP. But I type something in and that's a request. When I hit enter, that's a request. Or there can be a submit button that will send to the server not just the address of the page that I'm looking with, but the data that I've entered in the form and some other data about me as well. So these are all requests. Now, the web server is going to do one of two things with that request. If it's a request for a static page, by a static page, I mean a page that doesn't change, a page that contains only HTML. The web server has a very easy job of it because all it does is it finds the page and it delivers it. All right. Very simple job the web server has. It simply retrieves the page and delivers it. However, most of the time, in most web applications today, most websites today that do a little bit more than simply displaying data like a brochure, electronic brochure, the server does some work, and the server has a script on the other end, and you can think of a script as a little program. And the server runs that script and produces as output an HTML page. So with server-side scripting, the server runs a little program, oftentimes called a script, that takes any input that the user has entered in, like if they've entered something in a form, and produces as output an HTML page that gets sent back to the user, to the client, as a response. So we see the difference here between, and where does JavaScript fit in? Well, JavaScript is part of the response. We're going to send back HTML, we're going to send back CSS, and we're going to send JavaScript back to the client. When that JavaScript is sent to the client, then the JavaScript can execute. So there's the purposes of client and server scripting are as follows. Server-side scripting typically runs first. It is run to create the web page that the user is going to view. Server-side script runs as in response to a request by the client, and it is used to prepare a web page that is going to be sent back to the client. Part of what is sent back to the client can be JavaScript, and that JavaScript allows the user to make small changes in the page in content or in appearance or whatever without going back to the web server, which makes it a quicker response for the client. So the thing to keep, that's what we've done all along. We've started out with this part. We've created HTML pages that have JavaScript, and that JavaScript allows people to change the page. So if we, our coin example, we typed in the number of coins we wanted, and we selected what type of coin, we pressed a button, and we changed that page that was already loaded to include a certain number of pictures of a certain coin. All right. All those things were changes to a page that was already loaded. Now we're going to concentrate on server-side scripting, which is the preparation of the web page to be sent back to the client. Oftentimes, and we'll do this towards the end of the semester, a database is involved. So if you're shopping Amazon and you search for, a pair of boots, you're going to run a query. The server is going to run a query on the database to pull up all the products that match your search criteria. And they will be used in preparing an HTML page that gets sent back to the client. All right. Now, in terms of server-side scripting, the language is JavaScript. There really is no other language for client-side scripting. It's always going to be JavaScript. Now, in terms of server-side scripting, it can be any one of different platforms and languages. Those of you that are taking or will take CISS232, you'll do the same kind of server-side processing, but you'll use ASP.NET and C# to write your code. In this class, we use PHP. There's also Ruby on Rails. There's also Java in terms of either JSP or Java servlets. There's Python. There's a bunch of different server-side languages, but they all do the same thing. They all service the same role, and that is to prepare a dynamic web page to be sent back to the client. So let's start looking at PHP. That's our language of choice in this class. Let me open up Canvas. And let's look up at, oh, before we do that, important point. Before we do that, we need to be sure that we have a web server to process these server-side scripts. JavaScript is processed by the browser. So to run JavaScript, to run client-side JavaScript that modifies existing pages, all we need is a web browser. And we can open up our web pages in the web browser and we can run our JavaScript. With server-side scripting, though, it's different. The browser cannot consume directly server-side scripts. That script has to run on a web server. All right? So you will need to, on your machine, install a web server if there's already not one installed. And there probably won't be one already installed. A very popular one is XAMPP. And I have a little video that talks about installing XAMPP. So please be sure to watch it. I will not install XAMPP in this class because I already have a web server installed on this machine. I have Microsoft's IIS installed on this machine. Now here's a very key point, that in order to run server-side scripts, they have to be, your scripts, your web pages that contain scripts, have to be in a certain location on your machine. For me, running Microsoft IIS, it needs to be in C inet pub www root. It needs to be in that folder. That's the default home folder for IIS. If you run XAMPP, it will tell you where you'll need to store it, but you'll need to put it in a different folder. And the other thing is I can't just double click to open up the page like I could with a HTML document. I have to run it through the server, which means I have to request it through the server, which means I need to put in the web server's name and the location of the page in order to run the script and get the results of it. Let me show you what I mean. Here's some examples, PHP pages. If I look in there, I see a web page called first.php. Now, for this to run, I need to put it in my web server's home directory, which is C inet pub www root. So I'm going to go to C inet pub www root. There's already some default files in here. And I'm going to delete the default files. And I'm going to copy my files into it. Let me copy my file named first.php into it. So there it is. Now, if you run XAMPP, it won't be cinet pub www root, but you will be told the location when you install it. In fact, we could Google it to find out what it is. So default location of web pages in XAMPP server. And it will tell you where it will be. This is for Windows. Or is that Mac? Well, you could type in Mac or you could type in Windows and get the results. That was Mac. Let's type in Windows. And Windows would be put in that location by default. So you need to put your stuff in there. How do you know if your web server has been installed correctly? That's a good question. Well, and how can you check to see if you already have a web server installed? Open up a web browser and type in localhost. Type in :http://localhost. And this is kind of a funny way to show it, but this is telling me that a web server has been installed because I get something back. All right. A better way would be to type in localhost / and then put the name of my page in here. So let's do that. First.php. So I moved it into localhost. I moved it into CINet pub www root, and I type in localhost first PHP. I run it, and I get back some results. So this would be a good way to test if you have a web server running. Put first in its designated location on your machine, depending whether you run XAMPP or possibly running IIS. And then type localhost / first.php. And if you see this results, it means that you do have a web server running. If you get an error, probably you don't have a web server running and there's probably something wrong. That would be a great thing for you to make sure you get done this week. Make sure you have a web server installed. We actually have 2 weeks before an assignment is due, but don't wait till the last minute. This week, try to make sure that you have your web server up and running. Now, if we look at this, we see a regular HTML page. It contains a table that contains a number and the value of that number squared. From 1 to 99, I think, or maybe 100. Yep, 1 to 100. If we look at this and say view page source, we're going to see HTML. But the funny thing is if we look at this, all the HTML is in one line. It's in one line because code produced this. PHP code produced this set of HTML. Now, let's look and see what a PHP program looks like. So I'm going to edit this page. All right, first thing that you see is PHP document looks just like, has parts of it rather, let's put it that way, has parts of it that looks just like a plain old HTML page. So PHP pages contain HTML. They contain HTML for the static parts of the page. That is for the parts of the page that don't change. So for example, in this case, the title doesn't change for this PHP page, this first PHP page. This H1, it says this page was made via PHP. That doesn't change. We then have these notations, these declarations. And what they do is they tell the web server the code between here and here is not HTML code. It is PHP code. So PHP document is nothing more than an HTML page with PHP code interspersed within the HTML page. It must end, by the way, with a PHP file extension. So the web server recognizes that this is a PHP page and not just a plain old HTML page. All right, in this, we see one statement several times. That is the print statement. The print statement tells the server to send whatever is between the quotes to the client. So we're actually outputting HTML. We're outputting HTML to start a table tag. We're outputting a row of that table that contains 2 THs. And then finally, we output the end table tag. Here is really where we have the body of the table. And we have a for loop. And the for loop here works like the for loop in any other language you've encountered, whether it be JavaScript or C# or Java or whatever. What this loop says is for n equal 1, we're going to start the variable off named n at the value of 1. We are going to repeat this loop, and this loop is everything between these curly brackets. We're going to repeat this loop as long as $n is less than 100. And each time through the loop, we add 1 to n. So n starts at 1. We do this as long as n is less than or equal to 100. And each time through the loop, we increment n by 1. Now, notice something different from JavaScript and probably any other language that you've encountered. The variables start with a $sign. So I would probably even say the variable n, or I might say $n, but know that any variable in PHP starts with a $sign. Other than that, this could be a for loop in JavaScript or Java or C#. Next statement is an assignment statement. And just like JavaScript or any other language that you've seen, a assignment statement takes and evaluates the right side of the equal sign and assigns that value to the variable on the left side. So this is going to take the variable n times n, and it's going to store the result in a variable called s. Now notice something here. I didn't have to declare these variables. That's both a good thing and a bad thing. You might think it's good because, oh, that saves you some steps. But it can be confusing, and you don't automatically get an error if you don't create a variable. It just assumes and it creates a variable for you. Now this print statement, notice that there's double quotes in here. And when there's double quotes, whenever we see a variable name inside double quotes, it's going to take, and it's, instead of printing out $n, like you might expect, it's going to put the value of n. So the first time through the loop, n is going to have a value of 1, and s is going to have a value of n times n, or 1. Second time through the loop, n is going to have a value of 2. S has a value of 2 times 2, or 4. 3 and 9, 4 and 16, 5 and 25, all the way up through 100. And we output the HTML for a row in the table. Now, could we do this with could we include CSS in this picture? Absolutely. I could create an external CSS file, or I could include my CSS right on the page. And I could say, make the THs blue and make the TDs red, let's say. And there you see the THs and TDs are their respective colors. So the CSS on the page applies to all the HTML in this document that gets produced, whether it's hard-coded HTML or whether PHP creates it. So this is just like HTML that gets created any other way. In other words, we could hand type this in if we wanted to. But again, the nice thing is using PHP to produce this, it saves us having to create 100 different rows individually and hard code them. And it also keeps us from having to make any mistakes because the math is done by the PHP code. So it's a nice little feature of that there. Notice that I requested it from the web server, localhost / and I give the name of the script. And I put that page where it needs to be. In my case, CINet pub www root. If I just double click that page, if I try to open it up in a browser, it doesn't give me the correct results because I cannot simply open up the file. I have to request that file from a web server and let the web server process the script to get the results. This would be a good activity for you this week. Get a web server downloaded or check to see if you already have a web server running. And again, if you have any questions at all, let me know. And be able to run this script on your web server and get the results that look like this. Well, you won't have the colors in unless you make that same change that I did, but the output will look like that. All right, let's see. I'm going to contrast this with another version, it does pretty much the same thing, but the style of code is different. I have first two, and I'm going to copy it and put it in my web server's root. And I'm going to type in first to PHP. And it gives me the same results. Okay. Well, why did I do this if it shows the exact same results? Well, I wanted to show you different ways that you can code PHP. This is one method that I used. This does the same thing, but notice the way that it mixes HTML and PHP. In the first example, I have a block, a big block of code that is all PHP code. Everything within that section is PHP code. In the second example, I have little PHP blocks. In other words, I start my for loop here. I end my for loop here. Inside the loop, I have hard-coded HTML. Notice that's outside of those PHP directives. But inside the TD, I say to output the value of $n. And inside this TD, I say output the value of $S. I have no preference which way you do it. You can either make one big block that does the calculations that you need to do and outputs the HTML that's necessary, or you can have a bunch of little PHP blocks where the PHP is only around, the PHP tags are only around the PHP code, and any HTML you have is outside of the PHP code. I hope that's clear, the difference between the two. They both are a mix of HTML and PHP, but in this case, the PHP is outputting the HTML. In this case, the HTML is just HTML, and we're only outputting the PHP stuff, or the stuff that comes from the PHP script, interspersed with the HTML that's on the page. But they end up doing the same thing. The one thing I will say is this can be a little confusing to follow, because notice how this is written. The for and the end of the for are in separate PHP blocks. If you're not real careful with your code, and if you're not real careful indenting the code properly, you can end up with some very confusing code to try to figure out. And remember, confusing code makes it harder to maintain. And what is our criteria? What is one of our criteria of good code? Good code is easy to maintain. Now, going forward, we'll see where we can use functions and things like that to make it even easier to read. But do pay attention to the way your code is formatted, because that's a good first step in making your code easy to maintain, which is a goal of ours. It's a goal in any programming language, because, you know, invariably, there's going to be a time to change your code. I want to go over one more example today, and that is these pair of pages, form and first three. These work together. Let's look at how this operates first. And then we'll look at the code and see how it does it. These two work as a pair. I have form.php, which displays a form. It has a starting value, an ending value, and a submit button. So I can type in 4:16, let's say. I click process, and that calls first3.php and only shows me the squares within the range that I typed in. So I could go from 1 to 1200. And it does all of them. Or I could go from 1 to 5. And it does them. This illustrates a very popular use of PHP code or any server-side scripting language, and that is processing the values that come from a form. So this has two parts to it. It has the actual form itself, and it has the PHP code. The form itself is in a PHP file, but actually this PHP file only contains HTML. Well, you might say to yourself, well, why would I make it a PHP document if it only contains HTML? If I'm doing a website that uses server-side scripting and I'm using PHP, I'm going to make all my web pages PHP, even if at the moment some of them don't require any server-side scripting. Just for consistency, and just if I have to go in at a later time and add some scripting to it, I'll be able to easily do it. So this has a form, our label. I have a text box called with the name and ID of start, the name of ID of end, and a submit button with a value of process and the name submit. All these are grouped in one form. I don't have multiple forms. Think of a form tag as being like an envelope that you're going to send data to the server in. And the form goes around all the data that you're going to send to the server. Now, I have a method of get and an action of first3.php. What does that mean? Get means it's going to send it on the query string. It's going to send this data from this form as part of the query string. Action of first3.php means that's the name of the script that's going to be called when I press submit. So let's watch this. Let's go back to the form and I type in 10 to 50. All right. Those form fields are contained. I hit process and it sends it to this page. And let's take a close look at the URL. Let's magnify the URL. Localhost, that's the name of our server. All I said was first3.php, so it's going to assume it's in the same server because I haven't designated a different web server. I've just said first3.php. Question mark, start equals 10, end equals 50, submit equals process. Submit equals process means that the submit button was pressed. Because if we look, that button has a name of submit and a value of process. That way, if there were two buttons on this page, we could tell which one got pressed. Maybe there's an update and a delete button on a page. Well, you want to know which button got pressed. Do we want to update the information or delete it? What else do we have? We have on the query string start equals 10, ampersand, end equals 50. And that's the value of these respective text boxes. When you're passing data on the query string, the name is relevant. We put an ID because sometimes that's useful when we write JavaScript for it. But the name is the important one here. Usually, except for radio buttons, I'll make the name and the ID the same thing for a form field. So this is what passes data to this page called first, passes it on the query string because I said get. The value of this text box is labeled start equals, this one is end equals, and this is going to say submit equals its value or process. Now let's look at the page first 3 page. It's going to look very similar to the others, except it's not going to have hard-coded the value. We're going to instead get that value from the request that was made. So the start number comes from the thing on the query string that has a value of start. The end comes from the thing on the query string that has a value of end. Our for loop then looks just like it did before, except instead of having hard-coded 1 to 100 or whatever, we go from n equals the start to n equals the end. So if we type in 5 to 50, it'll give us 5 through 50. Does the same thing, squares the value and outputs it. We're going to revisit this next week as well. I don't expect you just after one lecture to understand it, but I would hope that this week what you can do is be sure that you get a web server installed and you can run these examples in the manner that I have run these examples today in class. If you get that done and you don't want to go any further with the next assignment, that's okay because we have 2 weeks to do this assignment. All right. So don't worry about that, but at least try to get the web server set up this week, even if you don't go further and try to complete the first assignment. We've actually covered everything that you need to do the first assignment, although it might not seem like it, but we'll talk more about that next week. Are there any questions? Yeah, go ahead. Go ahead and type in chat. In terms of PHP to produce HTML, is there a performance advantage? Chat disappeared before I could read the whole thing. In terms of PHP produce, is a performance advantage server side versus static client side? I'm not sure I understand the question. Is it more efficient to have the HTML hard coded? Yeah, it probably is, because that's an operation the web server doesn't have to do to run a PHP script to produce it. However, a lot of times we can't produce static HTML to do something. For example, if we were pulling data from a database, all right, we can't do a version of that in static HTML. All right. So therefore, and we can't do that via client-side scripting either. So by necessity, we have to use server-side scripting. Now, in this example, this specific example, yeah, if I had hard-coded a squares table from 1 to 100, that would work probably microseconds quicker than using the PHP loop to do it, because that's just less work that the server would have to do to produce the results. The second example, or the third example rather, where we entered that in, you couldn't do that with static HTML. I guess you could do that client side. I don't know which one would be more efficient. I guess that isn't a real concern, I would say. The efficiency isn't going to determine which way that you do something. You're going to do the stuff that you need to do server side, because there's either not an alternative to do it. Because there's not an alternative to do it otherwise. Yeah. All right, we'll either see you in lab or we will see you next week. Good luck, and let me know how things come out installing the web server.